All right, so if we read this, it says use the trapezoidal rule and the Simpson's rule to approximate the value of the definite integral for the given value of n. Round your answer to 4 decimal places and compare the results with the exact value of the definite integral. So here's what I did first. I went ahead and did the exact one first, just because it's comforting. All I'm doing, if I do this integral, if I integrate x squared, isn't it just x cubed over 3?
Yeah, so I have 1/3 x cubed.
Okay, you could write it 1/3 x cubed, you could write it x cubed over 3. And remember, to evaluate that integral, you say, okay, I take the top value, that's 2 cubed over 3 minus 0 cubed over 3, which is 8 over 3 minus 0 is 8 over 3. Let's go ahead.
1 decimals is 2.66.
Yeah.
6.
Let's go out. This is 4 decimal places, so we're going to do this. We're going to write it's 2.6667. Okay, so that's how we're going to write it. We can do this one. We've got rules for integration. The reason they're doing this is so that we can see that they want us to see that this is actually getting closer than you might think. Okay. Because, yeah, there's stuff like x cosine x that we can't integrate, but let me convince you by giving you some that you can do and seeing the results to let you see that it does get closer than you might think. Okay. So now let's do the trapezoidal rule, and I've got the rules on the board, so I'm not going to write them on the video. The trapezoidal rule says if I want to integrate this, it is b minus a. Well, what are my b and my a? They're these boundaries. Yeah, so it's 2 minus 0. So if I'm going to approximate it.
So it's 2 over 8, so it's 1/4.
2 minus 0, yeah, and now the 4 is the n. They tell us the n in the book. They want 4 trapezoids. So that's where he's getting the 8. 2 times 4 is 8, just plugging it in. So that's a fourth. You're right, that's a fourth. I'll write it down here. And then the function value, okay, if I'm going from 2 to 0, if you remember how we determined how we were going to increment our counting on our x's when we were doing the rectangles is we subtracted b minus a, and then we divided by the number of rectangles, except now they're telling us they want trapezoids. So it's 4 trapezoids, so it's 2 minus 0 if I subtract this 2 and this 0. And we want 4 trapezoids, so we're going to count by halves. So what I'm really doing is I'm saying I want f, I'm going to start at 0 because that's my bottom boundary. I want to know f of 0. And then I'm going to say 2 times f of a half because I'm counting by halves. So I'm going to plug in a half. This is where your graphing calculator could get really handy. If you put x cubed over 3, wait, no, we want the function value. We actually just want the x squared. We're not going to go to the integrated value because remember normally we couldn't even integrate it, right? So we're going to this y equal x squared up here that was the original function. And so that's not going to be hard to do, but let me just write out what it would look like first. Then if we count by another half, we'd be up to 1. I'll just take advantage of that b in there because I wish I hadn't written it. And then, let's see, if we add another half, that would be f of 3 halves, yeah. I'm going to leave it in fractions.
So is that 2f or just 1f?
Oh, no, it should be 2. I thought I was already done and I'm not. And then 2, now we're at the last one, and when I add the last a half, I'm up to 2.
So you just leave it as
So it's just f of 2, okay, f of 2. So now, I don't really need a calculator here if I'm, I can do this mentally because all I'm doing is taking this value that I'm plugging in and it's just, the function is x squared, okay? So 0 squared is 0. 2 times a half squared is a fourth.
So it's a half.
Yeah.
So 2 times
Okay.
1, that's just 2.
Yeah, 2 times, let's see, 1 squared is 1, 2 times 1 is 2, so it's 2 times 1. I'm going to go ahead and write this all out because I don't know who might be watching this in the future, and some of you can do this in your head, but f of 3 halves squared would be 9/4, so it's 2 times 9/4. Okay, you can.
So 4.5.
Okay, yep. Okay, so in our class right now, people are just reducing it as they go, so I'm going to write it down. And then 2 squared is 4, and remember, I don't multiply it by anything, it's just 4. So you could stick all this in on your calculator, and in order just to kind of cut to the chase here, when you do this, you get 1/4 times 11 if you were to, kind of do all that, but you could just plug it all in, and what I got when I did it was 2.7500.
Yep.
Now, that's not exact, but that's pretty close. Of all the numbers we could have come up with, it's decent, yeah. Now, if I wanted it more accurate, what I could do is increase my number of trapezoids. I mean, I could
Yeah.
make it 1,000 if I want to really get all worried about it, right?
That's true.
Okay, so they're just trying to be nice to you here. Okay, now Simpson's rule says that if I want to approximate that integral, and again, we would use this normally for things that we can't integrate, that don't integrate nicely, but they're just using these functions just so you can kind of see that they're getting kind of close. What Simpson's rule says is that I'm going to say it's b minus a, so 2 minus 0, upper boundary minus lower boundary, and the number of rectangles, they still want it, I mean trapezoids, they still want it to be 4, n is 4, so that's still going to be a half. And then if you look at Simpson's rule, it's the function value, we're still counting, if you think about it, didn't we do 0? We counted by half, 0, a half, 1, 3 halves, and 2. You know, if you write those up on the top of your paper in the problem, you don't have to go refigure them out from scratch on both of the Simpson's rule and the trapezoids rule. You're going to use those same values. But on Simpson's rule, it's going to be f of 0. Then you're going to alternate between 4 and 2. 4 times f of a half, and it's going to be plus 2 times f of 1, plus 4 times f of 3 halves, and you only use these on even functions. It's a f of 3 halves there. It's kind of hard to read it. And so you always just say that's just f of 2 at the very end, okay? So it alternates 1, 4, 2, 4, 2, 4, but you should always end up with a 4, and then the last one is always just going to be the function value not multiplied by anything. Okay, so it's a square, so that makes it easier. 0 squared, 0. 4 times a half squared is 4 times a 4, so we're now got, let's see if we simplify as we go, we got 0 plus 1. 2 times f of 1, 1 squared is 1, so we got 2 times 1 is 2. And then 4 times 3 halves squared is 9 fourths.
Times 4, which is, I don't know.
Which is a good.
Or 9.
9, okay. Because the 4s are going to cancel out there. And then I'm now down to my last value, so f of 2 would just be 2 squared is 4. So you're taking the function value and they're multiplying it by some number. If you look, there's just a different pattern for each one of these rules. So that's a half. 1 plus 2 is 3. 3 plus 9 is 12. And 12 plus 4 is 16. Wait a second. That's not right.
That's what I got. That's right.
I think I've done something wrong.
Because I got the exact answer I got in the first
Oh, wait a second.
That's right.
But I did something wrong up here.
Where?
Up here. 2 minus 0 is 2, but it should have been 3n, so 3 times...
Okay.
3 times 4, right, was 12?
12, so it's 1 6.
1 6.
Times 16, or...
Yeah, this should have been a 1
6.
6.
Or 6 6 6 7.
Yeah.
Sorry. I was wondering where it was like, I have it.
Yeah, I just, oh, part of it is 6, actually is,
I am very, very bad at memorizing formulas, so I mean,
well, you get to use your book
that's true.
on your test, okay? So 2.6667, that was actually exactly the
Yeah.
same thing as we got with the definite integral. So this one actually ended up being pretty close to the right thing, right? Even with just 4 divisions like that they gave us, okay? So this is what you're doing.